Okay, we're working on problem 8.1.113, which is problem 36 in the homework assignment, where we're going to find out how far a bicycle will move if this pedal is rotated through 180 degrees, which is also pi radians. And we know that the distance that this chain moves is related by the arc length formula, which is S equals R theta. Theta is in radians. So we also know that this chain length, the distance that it moves, is the same for the big wheel and the little wheel. What are different are the angles that the gear is rotated through and the size of the radius. So we know that for the big wheel, we'll see RB for the big wheel, theta B for the big wheel, and then this is going to equal the chain length that moves, the arc length. It's a linear distance, so it's the same for both of them. And this is R little times theta little. We know that those are related. So what have we got? We've got the radius of the big one is 4.82. The angle that we're going to rotate the pedal through is 180 degrees, or pi, which is useful because when we see theta in a formula like this, we're talking about radians, so we would have to convert it. And this is equal to the little radius, which is 1.58 inches, times, well, we don't know what the angle is for the little one, but we have one variable here, which is theta little. We can use this relationship to find out what the angle is for the smaller wheel. So theta, little theta, is going to be 4.82 pi over 1.58 inches. Alright, these are all inches. Now we have to think about the problem about where is the actual tire, the bicycle wheel. Well, the bicycle wheel is around this gear. This is the axle of the wheel of the bike. So now what we want to know is what is S going to be for the tire, because that will be the distance. Like if you pick a spot on the tire, as that spot moves around the circle of the tire, in a circle it's actually on the ground, it's drawing out linear distance. So each time it rolls, that spot that you marked on the tire hits the ground and goes up. Actually it's moving linearly. So this is going to be equal to the radius of the tire times the angle that the tire is going. Well, the angle that the tire is turning in is the same angle as this smaller gear, which is this guy up here, which is this guy over here. So this is going to be equal to the radius of the tire, which they tell us here, assume the radius of the bicycle wheel is 13.8 inches, and multiply that times theta t, which is equal to theta L, right? The angle that the tire turns through is the same angle that this little gear runs through, so it's going to be 4.82 pi over 1.58. And so that's going to give us the distance here. Well, what is that? That is 13.8 times 4.82 times pi, which is second on this here. And then I'll get that interim solution and divide that by 1.58. So it's it's 132.257, blah, 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 round to the nearest tenth. So this would be the tenth. Go to the right, 5 or bigger, we round this up. So S of t, which is the arc length of the wheel of the bicycle, and it's also the distance that the bicycle will travel, is, and actually this should be, this should actually say is approximately, because we are giving an approximation. It's 132.3 inches. Go over here, click in there, 32.3. Yay! We love that one, it's nice work.